Today we're going to learn the multiplication of index laws, and the way I'm going to do it is I'm going to just write down some basic calculations. 2 squared multiplied by 2 cubed. Okay, if you've watched my previous video, you'll understand that both of these numbers have the same base. 2 is the base, and on this particular one, 2 is the power or the index. On this one, 2 is the base, and the index is 3. Now, if I were to write that in factor form, we get 2 squared is actually 2 times 2, multiplied by 2 cubed, which is 2 times 2 times 2. Oops, I've written 3 there, excuse me. There we go. Now, if I was to pull those together, I can actually write that better in index form as 2 to the power 1, 2, 3, 4, 5. This is 2 times 2 times 2 times 2 times 2, which is 2 to the power 5. Now, if I have a look above, the bases are always 2. If I add together the index 2 and 3 together, I get 5. I wonder if this always works, as long as the bases are the same. Let's give it a go. Let's keep the powers a bit small so I don't have to write out too many factor form. Let's try 3 to the power 3 multiplied by 3. Okay. Well, 3, remember, if I was to write it in index form, could have a magic, a secret hidden 1 there. We don't usually write that, but we need to understand that it's not 0. It has a power of 1. Okay, let's now write it out in factor form. 3 cubed is 3 times 3 times 3, multiplied by 3. Well, let's have a look at what that could be written as, simplified in index form. 3 to the power 4. Okay, well, did that work? 3 plus 1 is 4. Seems to work. In actual fact, this is an index law called the Multiplication Law of Indices, and it's a way to simplify an expression if the bases are the same. So I'm going to write the general rule up here in pink. A to the power m multiplied by a to the power m equals a to the power m plus n. So remember, you can only apply these if the bases are the same within the expression that you're trying to simplify. We're not trying to evaluate when we're trying to simplify. Simplify means keeping the bases the same and writing it in index form in this particular instance. Do a few examples. Let's go 6 to the power 4 multiplied by 6 to the power 3. Okay, let's simplify. Are the bases the same? Yes, they both have a base of 6. So in order to follow the rule, the base has to stay the same. And then all I simply do is add the powers. 4 plus 3 is 7. So simplified, this can be written as 6 to the power 7. Let's do another one. 3 to the power 8 multiplied by 3 squared. Are the bases the same? Yes, they are. So our answer will contain a base of 3. And all we have to do is simply add together the powers. 8 plus 2 is 10. Now, where people can get confused is when there's a coefficient multiplying by a base to an index. So let's give an example. 2e to the power 4 multiplied by e to the power 2. Well, there's a coefficient here, which technically is a base in its own right, but it's nothing to do with this base here. It's just multiplying. And in algebra, when we multiply things, and certainly when we're simplifying, we don't have a multiplication sign. But we can multiply numbers together. So 2 can be multiplied by e to the power 6. Let's just check. Base was e. We have to keep the 2 there because that's a different base, but we can add together the powers of the ones that contain the same base. So 4 plus 2 is 6. What happens if there's a coefficient there as well? Well, let's just change that. Let's do 3e to the power 2 multiplied by 4e to the power 6. Okay, well, we can think about this in factor form by writing this out. Well, we know that e to the power 2 and e to the power 6 combines to make e to the power 8. But that's technically 3 multiplied by e to the power 2 multiplied by 4 times e to the power 6. Well, these bases are the same, so we can apply the index law. These two, they're just numbers that we can multiply together. And you can only do that if the power of each of these numbers is 1, which it is. So you can go 3 times 4, which is 12, e to the power 8. All right. What happens though if the bases aren't the same? Sometimes we can't simplify it. For example, 2 squared multiplied by 3 squared. We can't, I hope you can see that, we can't simplify that any further. But what about if we had, and I'm going to actually clear some room here, give me a second. So let's look at 2 multiplied, let's do 2 to the power 4 multiplied by 8 multiplied by 32. Well, they don't have the same basis at all. So we can't currently apply that law. However, what we can do is we can look at the number 8 and 32 and the fact that this is 2 to the power 4, and we can write 8 in a different way. We're not changing it, we're just going to write it as a base of 2 by thinking about prime factors. You can break any number into its prime factors. 8 can be written as 2 times 2 times 2 or 2 cubed. So in actual fact, I've already gone one step closer to being able to use this multiplication law of indices. Let's think about 32. If we break 32 down 8 times 4, we can break 8 down to 2 cubed and 4 as 2 squared. We can actually write 32 as 2 to the power 5. Some of you may already know 32 can be written as a base of 2. Now we all have the same basis. We can apply the multiplication law of indices just by simplifying. We're not being asked to evaluate or work an answer out. We were just being asked to simplify. So 2 times 2 times 2, bases are all the same. I don't know why I said that, sorry. Bases of 2, we have 4 plus 3 plus 5, which is 12. We can write that as 2 to the power 12. And that's pretty much everything you need to know about using the multiplication law of indices.